All right, so here's a business example. And so we have the rate of change of profit. And so a toy company can sell X electronic gaming systems at a price of P equals negative 0.01 X plus $400 per gaming system, right? So this is each, right? That's how much, what the price is for each of them. So that's how much money they can sell it for. And then the cost of a manufacturing system the cost of manufacturing X systems is given by this formula, right? So this is a total, right? So this is each, whereas this is all of them, right? So this is a total. Okay. Find the rate of change of profit. All right. So we have profit here when 10,000 games are produced, right? So that's when X equals 10,000. Should the toy company increase or decrease production? All right. So first of all, let's start by kind of making sense of this and trying to find profit, because neither of these equations is profit, right? This is the price per item per gaming system, and this one is the cost of producing or manufacturing X gaming systems. All right. So first of all, if we profit is basically revenue minus cost. All right. So that's what profit is, and profit is comes up a lot. It's kind of a common calculation that you have to make. A lot of times on standardized tests, but also in the real world, profit is definitely one of those things, right? It doesn't matter how much you make or what revenue you bring in if your cost exceeds your revenue, right? So you want to make sure that your revenue exceeds your cost, and have a positive profit, and you'll be making money, right? So that's just basically the fundamentals of business, right? You want to be making money. And so let's find our revenue. So that's not even given here, right? So revenue is going to be the number of items sold times the price, right? And so our number of items sold is X, right? That's what X represents. And then our price is P, right? So this function here. So we'll multiply X times negative 0.01 X plus 400. So if we have this, if we sell this many at this price, then this will be our revenue, right? So if we distribute that, we'll get negative 0.01 X squared plus 400 X. Okay, so that's our revenue. So what we want to do is we want to do this minus this, right? And so that'll give us profit. So profit, our profit function, okay, is going to be, and we'll call it P of X, is going to be this function here, negative 0.01 X squared plus 400 X, minus this function here, 100X plus 10,000. Okay, and so what will happen is we'll distribute this negative here, and so we'll end up with all this minus 100X minus 10,000. All right, so our final simplified profit function is this, negative 0.01 X squared. When we combine our like terms, 400X minus 100X is 300X, and then minus 10,000. Okay, so this is our profit function. And what we want to do is we want to find the rate of change of profit when 10,000 games are produced, right? So basically what we're trying to do is we're trying to find P primed at 10,000, right? And what that's going to equal is the limit as H approaches 0 of P of 10,000 plus H minus P of 10,000, right? All over H. Okay. So first, what we want to do is find P of 10,000. And so P or P of 10,000 plus H, I should say. So P of 10,000 plus H is going to be negative 0.01 times 10,000 plus H squared, right? Plus 300 times 10,000 plus H minus 10,000. All right. So I just plugged 10,000 plus H in here for X here and here. All right, so now we can just evaluate. So remember that we have a shortcut for this here. If we square it, we're going to get 10,000 squared, which is, we're just going to double the number of zeros here. So it's going to be 8 zeros, 1, 2, 3, 4, 5, 6, 7, 8. So that's a big number there. 100 million. Plus, we're going to multiply these together and double it. So that would be 20,000 H, and then we'll get plus H squared. All right. So then we're going to, we still have that negative 0.01 in front, so we're going to distribute that. And so we'll end up with negative 0.01 times this number is going to take away a couple zeros there, and it's going to change the sign. So it's going to turn into negative 1 million, right? All right, so we go from 8 zeros to 6 zeros, changes the sign here. We're going to take away a couple zeros and change the sign, so it's going to be negative 200 H. And then when we multiply it by H squared, we'll just get negative 0.01 H squared. Okay, and then we're going to distribute the 300 here. So we'll end up with plus 300 times 10,000 is going to be 3 million plus 300H all right, and then it's going to be minus 10,000, right? All right, so now we can combine like terms. So I'm going to just bring down the H term, the H squared term, I should say. So negative 0.01 H squared. Then I'm going to combine all my H's, negative 200H, and 300H is positive 100H. Okay, and then we have negative 1 million plus 3 million is positive 2 million minus 10,000. So 2 million minus 10,000 is 1 million, oops, 990,000. All right, so that's what I'm going to put in here, right? So I'm going to put in negative 0.01 H squared. What else do we have here? Plus 100H plus 1,990,000. Okay, so now what I want to do is find P of 10,000. All right, so I'm going to put a P. I'm going to put a 10,000 every place these X's are, right? So it'll be negative 0.001 times 10,000 squared plus 300 times 10,000 minus 10,000. All right, and so what we'll get is 10,000 squared we saw before is 100 million. Okay, and then 100 million times negative 0.01, we saw that before, that's going to be negative 1 million, right? Okay, then we have 300 times 10,000, which we saw before, which is 3 million. All right, and then finally, we have minus 10,000, right? And so we combine all those together, and we actually did that calculation before, right? It was exactly the same as this. And so we'll end up with the same thing, 1,990,000. So that's what we're going to put in for this. And so it'll be minus, and then it'll be 1,990,000. And that pattern continues, right? Where our variables are, where the constant cancels out. Let me put everything else in here. Okay, so the constant cancels out, and then we can just factor out an h here, right? And so we have h times the quantity of negative 0.01 h plus 100 all over h, right? And before we couldn't plug in 0 because we had that h in the denominator, and that would give us a 0 in the denominator, but now these h's cancel out, and so all we're going to have left is the limit as h approaches 0 of negative 0.01 h plus 100, and we can directly evaluate that, right? We're just going to plug in 0 for h now, and this turns into 0, so we're just left with 100, right? So the profit, the rate of change, the instantaneous rate of change of profit, if we sell 10,000 items, is going to be 100. All right, so remember, this is the rate of change of profit at 10,000 units, right, or 10,000 games that are produced. And it says, should the company increase or decrease production? Well, if the rate of change of profit is positive, 100, that means that the profit is increasing as we increase items sold, right? And so that means we definitely want to increase the items produced, right, or the items sold, because that will increase our profit. And so the answer would be yes, since the rate of change of profit, right, which is what this says, at 10,000 units, is greater than 0, increasing gaming systems, or increasing production of gaming systems, right? Increasing production of gaming systems will increase profit. All right, at least at that point, right? Like there could be a point when increasing them decreases, but at that point, yeah, we should definitely increase the production if possible. All right, so here's an example of where we can use a derivative to help inform a decision that we can make in business, right, based on a profit model that we have of manufacturing gaming systems.